This is the beginning of the technical assessment on building the small order, the shopping application. I'm be using Visual Studio Code as my IDE, and I've chosen to go with Python for the backend. More specifically, Fast API. It's a bit lightweight as compared to Django. Yeah, I think those are the technical details so far. So I'm going to begin with the requirements document. In other terms, the requirement.txt file. I'm going to list out the requirements for the entire project. Also to note, I'll be using Django, not Django, but Docker and Docker Compose to manage the multiple services, Redis for the caching, and Nginx for load balancing. So let's begin with the requirements.txt. Okay. So under the requirements, the first one is the Fast API, which is a bit obvious. Now I'm going to go with, I think the current, I'm going to go with 0.1, 04.01 as my version. It's a bit lightweight. UVCon, it's a service that is similar to ngrok, but a bit standard for production application as compared to ngrok. The standard version, and go for the version 2.4. Then we have SQL Alchemy. Go with version, I think 2, yeah, 2, let's go with 23. Which other one do we need? Oh, Redis, we need Redis. Let's go with version 5.0. Let's go with, oh yeah, I almost forgot Pydantic. The other one is Parslib. Bycrypt version, which version? I think it's 1.4. Not sure on the version. We'll see if it throws an error. Then we have Python. Cryptography. Let's go with T3. Multiparts. Point 6, and then we're going to conduct tests, of course. That is on our main application. Therefore, we're going with 7.4.3 PyTest. It's a testing library to make our work easier. IO. Okay, let's use 0.1. Then we need to make HTTP requests. I'm going to be using HTTPX 0.25.2, not 10.2. I think that's it for the time being. Those are our primary requirements. If we have any more requirements, I'll be adding them as we continue and as we debug the application. So the next part, I think, we'll dive into configuring our main application. That is using the first API, main.py. Yeah, I think main.py makes sense. So there are a bunch of functionalities that we're going to do. Okay, based on this new, we are supposed to build a minimum order service. We're supposed to have an auth for sign up, login, orders. Okay. Okay. Then we have role-based. Okay. Idempotency on the orders using the client tokens. Concurrency, validation, and errors. Okay. Limiting open API Swagger documentation. Okay, so we chose to go with Docker and Docker Compose. So we are going to need a database to store the user, that is the regular users and the admin, and then we're going to need what? To store the orders. So we are going to configure our database and our caching mechanism. For caching, we've decided to go with Redis. So we are going to configure the two. And let's see if there's anything else we need to add. Oh, okay, part 2, we have the caching, retries, okay, and webhook. So we are going to configure webhook, caching, and our database, and what else? Then we might decide to do some logging, that is for observability principles. I think the best approach is to use counters, just like Prometheus. So let's begin. Let's begin with our setup. Okay. Let's do some configuration. So we are going to have all the main application requirements in one file. We're now going to divide it into multiple files for easier management. So let's begin with the database URL, which is to os get okay, autocomplete. So we are going to import OS. Okay. Okay, SQLite test.db. Okay, let me enlarge these. Test.db. We're not doing a test. Let's do something like orders. Orders.db. And then let's go for the second part. We have our secret key. Let's set up the secret key. OS.get environment secret key, your secret key. Okay, we're going to change the secret key later on. Let's set up the webhook secret. It's the webhook, not URL, but secret. We're going to use os.get environment and then set up our webhook secret as your webhook secret. We're going to update those later on. Then we have in our caching, remember we talked about Redis, so we're going to use the Redis URL. Similar. Okay, let's see. localhost, we're going to use port 8080 for development. Yeah, port 6379. Okay, it falls under good range for the free ports. Then API, not yet. We're not going to set up that one here. So the second thing to do is, we said we are going to be logging something like Prometheus, of course a bit lightweight. So let's go logging. So we're going to use the basic config. So let's go logging basic configuration. The level of logging. Okay, autocomplete is doing its thing. Get logger. Okay, that should be it. Let's see. Not defined, which we're supposed to be importing logging, import logging, import logging. Okay, nice. So now after the configuration, we're going to set up our databases. Database setup, base setup. Okay. So we're going to begin with the engine. This is where the SQL alchemy comes in very handy. Database URL, session maker, not yet. Okay. We are going to have some arguments, the connect arguments. Connect. Seems autocomplete is okay. It's working. Yeah, we're going to set it to false, so that is correct. If the autocorrect is quite good today. Okay, so from there we're going to we are going to import the create engine from SQL Alchemy. Then we have the session maker with the autocommit set to false, auto flash false, and bind to the engine. Then we have the base, we have the declarative base. We're going to import all of those from SQL Alchemy. Let's go. Okay. Okay. Oh, nice. Import declarative base. .orm import session maker. .env. We are not dealing with .env at the moment. So we're going to import the session maker. And do we need to import anything else? No. So we're having an issue simply because you've not yet installed the SQL Alchemy. We're going to do some pip install, either locally or through the through the Docker images, and install our nini. So now the second thing to do, we're going to set up our Redis. We talked about caching, so Redis setup. Okay, so it might fail. So we do not want our main application to fail as a result of cache misses or invalid cache setup of Redis. So we're going to use a try. In some languages, it's usually try catch, but in Python we have the try and except. So we're going to set up the Redis client. So you remember in our requirements document we have Redis as a requirement. So we're also going to import Redis from the URL we had configured above, the Redis URL. Okay, nice for the autocomplete to come in handy. We are going to ping the client. Okay. We can do log now. Yeah, we can log, it's no issue. Then we have a bit back, then we have except what? Except. So if an issue occurs, the Redis client is going to be configured to none, and then we're going to log, but we're going to begin with configuring the Redis client. Client is equals to none. Okay. Okay, we could say could not connect to Redis. Caching will be disabled. Okay, let's try something. That makes a bit of sense and a bit okay. Nice. This one makes sense. Caching will be disabled. It's two variables. Caching disabled. Makes sense. Redis is not available. Okay. Caching is disabled automatically. So we're not going to have any cache. So we have an issue with the Redis. So we need to, okay, this one. So we need to import Redis. Okay, we can just import from anywhere. Import Redis. Again, the highlighting, this highlighting here is simply because we've not yet installed Redis in our environment. We're using the local environment, but later on we're going to move to Docker. Okay, yeah, Docker and our images. So the second part, it's how we are going to handle passwords. That is for the regular user, the general user, and the admin. The best approach is to hash. So we're going to do a password hashing. Password hashing. Password context. By crypt going to deprecate it automatically. Okay. I'm going to import that later on. So let's set up enums for classes. We have the class, not the order status, but the user role. That is the admin and the regular user. Okay, nice. Then we have the class. We have our order status. We have the pending, paid, and cancelled. Those are the most popular statuses. Okay, autocomplete is doing its thing. Then from there, those are the only enums that we need at the moment. So the second part is going to be setting up our models and in form of classes. Oh, nice. We have a class and it's a user base. Okay, nice. Okay, this autocompletes can't be trusted sometimes. So and the user, we have the table for the users. Yes, that's correct up there. ID, we need a primary key. Okay. Index set is to true. Yes. Yeah, up to there it's a bit correct. Let's delete this. And yeah, let's focus on the user details that we're going to extract from the user. That is the email. As a string, is it unique? It's supposed to be unique, yes. Index true, yes. Nullable, false. We must have an email, so nullable, no. Then we have to have the hashed password, the password that we just hashed above. It's supposed to be a string. Then the next part we are going to the role, that is either the regular user, we have here the admin, or the other regular user. So let's see, role, actually role is equals to another column, is going to be an SQL enum, is SQL enum. No, not alchemy. Right now we are not using alchemy. The user role, our enum. Yeah, the default user is supposed to be the regular user. Yeah, I think that's a nullable, not set nullable to false. We must get a user role. Then we have to track when the user was created or when the user logged in. Date time, we're going to import the imports later on. And now, okay, so I'd say that's our first table for the user. It's going to come in handy when we are doing the authentication. That is the sign up and the login. Then we have the order. It's going to stand for the orders. So the table name is correct up to there. It makes sense. Then we have the ID, auto increment, primary key. Index is true. Okay. Then the other part we have the user ID, the product ID makes sense. Quantity. Okay. Okay. Status. We're going with SQL enum. Okay. Let's just handle it up to, let's just handle it manually. It makes it's a bit cleaner. Table name is equals to, sorry, orders, delete. So now we have the ID. Okay, let's just do that for now. To the ID. Now let's focus on our own implementation. We have the column. The other column, of course, is the user ID. User ID and column. User ID is supposed to be another integer, and it's supposed to be nullable, set to false. Integer. We're not going to go into the complexity of the foreign keys. No, not today. Nullable, set to false. Must be there. Then product ID. How about the products items? Okay, let's see the items ordered. Column, JSON. No. Let's use just regular text. And it should not be null. The user should not be able to enter. Should not be able to enter an empty items to our database. So we have what else? Total amount. Yeah, I think that. Yeah, that makes sense. Should be in float. Yes. Then we have the client token. I almost forgot client token. Yes, we have a column. It's supposed to be a string, unique, definitely. Yeah, that makes sense. What else? Should be an index. No. It shouldn't be an index. Yes. We have amount, status. Oh yeah, status. Status. Status, order status. We have the status above here. Then default, pending. Then nullable, of course, it's not supposed to be false. Okay, makes sense. What else is missing? Okay. Okay, what else? Okay, the database. Let's see. We have created it. Sorry, updated it. Makes sense. On update now. Okay. So these one are our logging metrics. They created it and updated it. Okay. Let's just write it as matrix. Okay. Before that, we have to have not payment, but the version. Oh yeah. Let's version it. That is for preventing locks. I'm initiating locks. Okay. It's going to come in handy when multiple users attempt to access our DB, the table or update a certain item. So then the other, yeah, we were going to handle payments, so it only makes sense to store the payment retries. We have a class, not webhook log. Let's say payments base. Okay, let's call it payments retry. Makes a bit of sense. Retry. Then we have our base. Okay, let's tab that. Okay, payment retry. We're going to store retries. Okay. Primary key true. The order ID is nullable. False. Yes. Attempt count. Okay. Order ID. Last attempted. Next attempted. We don't have the next attempt at the moment. So after a payment fails, we have the error message. We can also record that in the database. Error message. Column text nullable is true. Yes, it can be null. Last attempt, then next attempt. I don't think this is viable. I don't know when the user is going to make the next attempt. We have attempt count. Let's just call it retry count. It's a bit cleaner. Retry count. Okay. It's an integer. The default is 0. Okay. Nullable false. Okay. Then what else do we have? A payment ID. Yeah, payment ID. We have the order and the payment ID. Should be what's can be a string. We might need to change this later on. Then let's see what else we need. This is something like status. Definitely a string. We're not going to use the order status, the SQL enum one. Error message, last attempt. Okay, reduce that. I think that's it. Then we're going to create our tables. Okay, nice. Base, metadata creator, bind engine. Bind is equals to engine. Makes sense. Okay. Then log that. Then we have our models. Since we have the pydantic models. So we are going to begin with the user sign up, then login. Then from there, order item, I believe, sign up, login, yeah, the default, sign up and login. And then we have the order, yeah, we need to create an actual order, and we need the items. And what other model do we need? Login authentication is handled by login sign up. We have the, I think those are the, then payments. Okay, I think that will fall under the webhook. And do we need a model for status? I think we also need a model for status. Okay, so we begin with the authentication models, that is the sign up and the login. So we have our class user sign up. User, is it sign up and sign up? Yeah, the login is different. So we are going to be using the email and the password. The password is a string. It validator for the password. So the password must meet. Let's just keep it simple. For the most complex systems, you have maybe what? Capital letter, maybe a different name for a number, a letter, but let's keep our validated length only. Let's do 6. 6 makes sense. Should be at least 6 characters long. And yeah, I think that's the only check we are going to do under the sign up. Then we have the user login, also taking in the email and the password. Don't think we are going to do any validation since the password is already set. Then the other we were to create an order, then the items in the order. Okay, let's do a class of order item. Item base model. We have the product ID and the quantity. Okay. Not quite. Let's see. That is what we are going to start doing at the moment. So let's proceed. The first thing is, when we are getting a list of orders, the user can only see their own list of orders. So if request user role dot just a regular user then query. We are going to filter now, and we are going to filter the order user ID by the current user ID to ensure that you only see your own orders, not other people's orders. If status, then we're going to filter by status, then order status. Okay, let's see. Do we expect an error? Yeah, we could have an invalid status. We could have an invalid status, so we are going to use try and then query the DB. Before we query, let's get the status in. Is equals to order status dot status. I think we should upper this the upper function, and then from there then we have to query our query and then filter it using the status and the status in. If there is a value n that is going to occur, then yeah, invalid status, not status filter, but essentially an invalid status. Okay, so then the other thing we're going to do is we are going to search by SKU. Okay, let's just put SKU search, SKU filter. So let's just perform a usual query. Query is equals to query the filter order dot items, then it contains our queue, SKU. Then the other part we're going to do pagination offset, and let's make sure we return a particular number of items per page. Page minus 1 times the limit, yes, makes sense. Then let's do a total. Total is equals to query count. Okay. Then we get the what? Then we get the orders, all of them. This one is just a variable. Offset is just a variable. So then we're going to return our results. Return. Essentially, it's a list of orders. It's not like it's one particular item. It's just a list of multiple orders. So we have our ID, the order ID, and we have our we have the status, and we have the items. Yeah, that's true. We have then the total amount and created it. Do we add the updated data and give it a name? I think let's just include it. It's not that crucial. Updated it. Okay. Okay, for order in, the list of orders. Then from there, what else do we have? A total of the orders and the page sizes and the limits. Okay, let's include the pages, number of pages that we have. Now, the next part we are going to delve into is the orders with the get a particular order with the order ID. And let's continue. Order ID. Order ID, which is an integer. Then we can have to get the current user from our database. Then passing the database session, just as usual. And we are going to return at the moment nothing. So we're going to check our Redis database. So we're going to check our cache. If there's anything in the cache, if not, then we're going to query our database. So cache key for the key is equals to cache key. Then we have the okay, nice. Cached is equals to get cache and then passing the key. If cached, nice, then we're going to get our data from the cache and everything there. We have the JSON load of the cached, and before anything else, before we return the data, we also need to do a role-based access. So we're going to need an if statement to check for the role. Okay, let's see. User role and the data user ID is not equal to the raise of should we raise of all three? Let's see. Then return the other data. Should we raise the current user role is equals to the user and the order data. I think it means that the order for that particular user is not available. So in actual sense, it's not an authorization access issue. It's just that the order is not in our cache. The order for the particular user is not in our cache. Order not found. So it's a 404 error, not 403. Nice. Else if it's found, then we return the data. So now we are done with our cache, that is the Redis. In case it's not there, then we have to hit our database to query for the order. We're going to filter depending on the order ID, then we get the first. Then if not order, we are going to raise an error 404 or order not found. And then we are going to do role-based access again. Okay. And assuming now the order, the user ID on the order and the current user ID, they do match, then it means we have our order data in our database. So we are going to return the order data, and after returning the order data, then we are going to pass the data into Redis for caching. So next time we are going to try to access the data, we are not going to have to go to our database, but we are going to actually access it from Redis. So we have the version. Let's include the version. The moment we've been leaving it out for a while. Yeah, that seems okay with me. We have our order data. Then let's set the cache and cache key, and then dump the order data, and then return the order data to our user. Nice. So the next part we're going to deal with the status. Not okay. Yeah, we're going to patch the status. Status. So this one is get on is status, and so we will be updating the status. Okay. Sorry. In order to update the status, we need the status data, get the current user, pass in our database session, and the order ID, which is an integer. Net database and return. Okay. So we are going to get the current order from our database is equals to db.query order, and then we're going to filter by order ID. Oh, sorry. Filter by order ID. Yes, for update now, we are going to ignore this and return the first, depending on the order ID. Yeah, then we're going to do a check. If not order, we're going to raise an error, that is the 404, not found. Then you remember the version which was being used for locking. So now we are going to do something that is known as an optimistic lock check. A locking check that is using our version. So this is where it comes in handy. So if status data, let's get the version from the status data dot version is not null, then what do we do? And the version, oh nice, and the status data version, not actually the status data, but let's do the order version. from the order queried from the database. Let's do that. Order version is not equivalent to, essentially it was the same thing. Okay, it's just the status data not equal. Okay, makes sense. So we're going to return a 409 for the conflicts. Then from there, let's update our status now. Our status is ready to be updated. Order status, status data. Okay. Then let's increment our version. Then we're going to also update the time that the order was updated again. So then we're going to commit everything to the database using the try except to roll out any integrity errors that might occur during the process. So we're going to commit and then refresh and invalidate the cache. So by invalidating the cache here, we're going to delete the previous order that is in our Redis database, and from there we are going to commit the new order, the updated patched order. Okay, so minutes. So we have the ID and then the status, version, and the updated. Those are the only things that have changed. So sorry, we have the, okay, let's just to amount on the items. No, we're done with that. We have the ID, status, version, and then the updated it, the only things that have changed. So that is what we are going to return. If an error occurs, okay, assuming the error is a DB, except, okay, rollback. Okay, yeah, status code 500 makes sense. So now we're going to deal with payments. Payments /gets. So to initiate the payment, we need to have the order ID, current user, and our session. So checking the order, then using rollback. The rollback can also label it as 404. Instead of not authorized, we can have like something like order not found, since it means the order does not exist for the current user. It exists for a different user. And let's see, order status is not equal to pending, so it's not possible to pay for the order. And then we have the payment ID, which is okay. Let's say it's just a customer. Let's generate a string, cast it into string, and then UID, unique user identity, and let's get the amounts. Is equals to cast into integer. Okay, makes sense. Times 100. It's not a must times 100. It's just times 10. Then from there, we're going to return our payment ID, order ID, the amounts. Okay, let's see. Order. Oh, yeah, we're supposed to ignore that. This one does not make sense. It makes sense, but not at the moment. Let's just go with the total amount from the menu. Okay, let's just okay. Redirect URL. Essential when dealing with things like Safaricom, but okay. So then the next thing we're going to do the webhook. Process webhook with retry. That is the retry logic for the payments. So we need the payment ID. Payment ID, which is a string. Essentially the UUID that we just generated. And we have the order ID, have the status, and we need the retry count. Order ID, status, and then retry count. So not essentially a database, but a retry count. No, we don't need that database at the moment. So let's just get that, and then try. Get the first using the order ID, and then what else are we going to do? Order status completed. Should we have completed? Let's just have paid. Okay, completed makes sense. Okay. And what else? Date time now, and then the version. We need to version this order, and the version +1. Okay. And then commits. Then load the metrics, then invalidate the cache, and then log the info. And nice. Then let's do a DB query on payments retry, and then filter. We're going to filter for the payment ID. Payment retry. It as payments. Okay, makes sense. But payment ID is equals to the payment ID, and the order ID is equivalent. Then let's do delete in the database and then do a commit and then do accept an error. Although this time it's going to be an exception. Exception is A. In case let's do a rollback, database rollback, and then retry count less than 5. Okay, makes sense. Maybe 5 for 3 times. Then we're going to have a retry entry, and okay, makes sense so far. Okay, db.commit, retry webhook for payments. Okay, can retry that and sleep for okay times retry count times okay process webhook with retry and passing our ID. Okay, that makes sense. Okay, and the retry count else and yeah, and finally I should do a database close. Nice work. So now the other thing is post, but we're going to do a payments webhook, the inverse payments slash webhook. I think okay. Let's see what we're going to pass in. We're going to pass in the requests. We have the usual request that we have. Signature. Signature for header. Okay. And yes, like signature. Then we are going to deal with the body. Body is supposed to awaits the request body, and then expected signature. Let's do a H mark. Signature for web. Let's do the webhook secret encoded. Then the body SHA-256. Then let's do a digest. Okay, that check seems valid. We're going to confirm later on, and let's do a try on our payload. Our payload essentially is a JSON. JSON.loads our body, then our webhook data. We expect an error to have a 400, that is an invalid payload. Then we're going to process the webhook asynchronously, that is with the logic, with the retrain logic. Actually, the retrain logic is the exponential backoff logic shown by this multiplication by 2 to the exponential of the retry count. It is this one. So this is an exponential backoff retry function. So let's continue. We're going to have the background tasks, and the task we're going to add is actually the process webhook with retry. It's going to need the payment data, our order ID, and the status. Then from there, we have to return our status as accepted, in other terms, you can return it as received. From there, we can deal with our metrics. Get metrics doesn't require necessarily to be. We're not going to set the role for the metrics, just return the metrics, just as easy. Then, yeah, I think we can just complete that. And Rubicon, our host, let's run. We need our ports. Port 8000 works. We don't need to import JSON. So we can also return. We can also decide to give health, the system health. Sync dev health check. Let's just ignore. Let's just continue with the metrics. I think metrics will work for the time being. And I have some few inputs. Needed hash nib. HMark, the time function that we used, import JSON, user ID that we used, the sync IO, time delta, enum. We're also going to need a list and option, traps, and now we need to import the functions from Fast API, the security functions, the middleware, and we have the validator, the @validator function that we were using to validate our password, the password length. Then we have the JWT token error and the JWT. We have the encryption, then SQL alchemy for our database. Okay, actually, we already imported the OS. Okay, and login at the time. Okay, seems like it's a repetition of what we've already done. So SQL alchemy exit. So we've finished with our imports. I don't think there's any other import we need. Let's check if there's an import that we may have missed. Okay, I'm going to check on that in the session. Okay, so our next approach is basically to to do what? We're going to, we also need to run some tests. That is our main application tests. Test main.py. Okay. Oh, nice. So we are going to be using PyTest. Import JSON. We're also going to need hmark and hashlib. We're going to be using threading, and not to forget time threading. And also not to forget time. Time is crucial. And now we're going to be using fast API from fast API. Dot test client. We're going to import the test client. Okay, for main, let's also do from SQL Alchemy. We're going to import the create engine, also from the ORM, the session maker, and from main, we're going to import a bit of things. We're going to import the application itself and get database, then we're going to import base. Let's first delete the models. Base, okay, sorry. We're going to import the user, and order status, then order status, then user row. Yeah, I think that's all for our imports. Okay, we import the other things on the go. So set up the DB. We are performing a test, so it's basically a test database, and the engine, the SQL Alchemy database connect, checksum thread setup as false. Okay, and then the session maker, we have autocommit, yes, and then we're going to bind to the engine. Yes, so far so good. Bind engine, yes. Then we start to override our database. Then try, yes, works. Then we have to get the app dependency to override our database. Then we get the client and initialize the test menu, the test app. Yes, so the other thing, attempt to use the, oh sorry, close that one. Attempt to use the, attempt to use the PyTest fixture. It's not for the module, but we're going to set it to auto true. So use true. Then we are going to clean our database, clean DB. Okay, I wasn't expecting this. So DB is equals to the session local, and then we query the order and delete it, query the user delete, then commit them, we close the database building, not really. Then we have to create the test user, create test user. We need to pass in the database. No, we can just initialize it, passing the email, password, and the role. We have email set to string, and the default as test. We can just set it as test at example.com. Sorry, example.com, and then we have the password, and then we can set up the role. Password. Let's just beef it up to user role, or you can set that to user, just a regular user. Let's set this to string. Then initialize our database. db is equals to test locally. Okay, but first, before initialize, let's get a response. Post to client post is not an endpoint. Our endpoint is auth, and sign up. And then we have our JSON data as our email and password, and okay, we have the role also. Then let's set our status code to 200. Then okay, if role is equals to admin, okay, let's do the commit and then close, and return our response.json. And get all the token. Let's get the token. We have our email and the password. Okay, let's just copy this. Email and then the password to get our token. Then we are going to be logging in, passing in the email and the password with the response code to get a 200 status code, and return our access token as a JSON response. Then from there, what we are going to do, we're going to have a class to test our authentication. And the first one, we are going to test sign up success. The test success, passing the self and our JSON. Again, we are going to use the data that we had previously copied. So, our email, has to be JSON compatible. So we have our email and password, and let's close that. And our search response should be 200 status code, and then you have the data, and we can do an assert for the email. No, assert email is equals to the email that we've used, test at example. Okay, let's use new. Let's use new. Okay. We can also do an assert for role, but we're not going to do that. Then there are various tests that we could write to test our application. We can also be testing the webhook, but for now I'm going to leave it at the sign up success and the authentication token and the login. You can also test for the metrics. Sorry. So for now, due to the time constraint, I'm just going to leave the tests basically there. So it's the file, and then we have our v. So that is our test file. That is the test main.py. Other than the tests, they were testing the main application. Something we also have to have is the admin, the HTML. So the HTML mostly was supposed to contain the bigger part of the, not the bigger part, but the slimmer admin UI. The framework of choice for the frontend has been, which was it? React. React is the frontend of choice, the frontend framework of choice for the admin UI. It's about 2 pages, it's going to be about two to 3 pages maximum. Yeah, it's going to have the login fields. So for the doctor. Okay, we have the viewport, order service admin, title, order service admin. So we have some, after the title we have some scripts. So I'm just going to include them directly. We have scripts. Okay, so since we are using React, not jQuery, React 18, it's 17, it's open for 18, to use 18. So we have that one, and we have the second script. Okay, we have the DOM, also the 18 version. Okay, React DOM.development.js. Then we have to okay, Babel. I'm going to do a standalone version of Babel. I think so. Okay, let's see. Okay, at Babel. Babel dot main.js. Yes, no, let's just go with tailwind. It's a bit cleaner. Scripts SLC is equals to HTTPS and CDN content delivery network tailwind.js tailwind.css and the end of our script, and that's it. The next part we are going to style, we're just going to style it inside the header. And so, okay, we are going to have some few elements. So before we start, okay, let's just continue the body. Define some elements. We have the root div. Then we have the scripts. So under the script, we have the const. We're going to have the use state and the use effect and use callback. Use state, use effects, and use callback. Here's the use callback. Yes, and then we have our API base. Which essentially is just the localhost, not 3000 but 800. That is our endpoints. Then we have the toast component, and let's create the toast component that is for the toast. Okay, we're going to have the message and the type and the on close function and the type. Okay, type seems to be missing out. Type, and then on close. Then we have the use effect. Okay, let's increase this to 4000 and clear the timeout and on close. Then we have the return of a div. Okay, let's see. We're not going to dwell so much on that part. And is that okay? Then we have the toast and the type. Like that and that. That. From there, we can proceed with. From there, we can set up another div with a class name. Okay, let's see. Div class name not close, this time not close. Let's just flex the items, flex items, then justify, and then justify, justify between flex item. Let's just center the items, center, okay, nice work, and click, ignore and click, then, okay, let's agree that X. Then inside the div, let's do a span of the message. And then let's have a button. Button. Oh, sorry. Button and click close, and then the last name wipes. Okay. Not bad. And then let's close the button. Let's have the button be an X. Okay, nice. So now we have to return that, and then let's create the login form. Const login form is equals to login. Okay. We have not the username but email. Of the email set email, and then we have the password, set password, and then we have loading, comma, set loading, the initial state is false, and then we have the error state, and okay, we can set it to null and the empty version, and handle submit, prevent default, yes. Then we are going to set the loading is equals to true. Set the loading to true. Okay. Set the error. The error we can just set it to empty or null, and then we have to and then we have the password, we have the text version, input of the text, not set username but set email. Okay, set password, correct, and okay, nice. Then before we can pass over submit, and login, how is the okay. Just a minute. Okay, let's see. I'll try. Const response. Wait, okay. Not admin, but auth login. Okay, and then passing the credentials with the post method. Then we're passing in the email, the username, by the email. I'm passing in the email and the password, and then we wait for what? We get an error whether the login has failed and whether we have a network error. Then finally we are going to set the if there is an error, we are going to set the error, and then finally we are going to set loading is equivalent to false. Okay, if the response is okay, we have what we have to get a token from on login. On login, we get the data, and then we have the access token. Or essentially, let's just do a reverse on this one. Assuming it returns an error, then we are going to throw a new error. Login has failed. Else we have conf data is going to await a JSON response from the server. Then we are going to do a role based to check if the role is an admin or just a regular user. If it's not an admin access required. Yeah, not an admin user, makes sense. Then we have local storage. Where we're going to set our token and the role. So we don't have to authenticate each and every time. We can just use the token, and if the role is required, then we have the role. We don't have to keep authenticating each and every time. Data.role. Okay, nice. Then we have on login, then the data access token. Login. Login. Data. The access token access token. Okay, nice. Okay. We defined that on twice. Not a nice. So we have our login form. Okay. So from the login form, we are able to authenticate the user, either as a regular user or an admin. So let's set toast, not toast but style. Nice. So we have the style for the body, for the toast, for the success, error. Okay, nice. Let's see what else we have. Okay, we have to set up the loading animation. That is, if the loading status is set to true, loading. Infinite. So that is our loading animation. So let's have it spin. So 8 keyframes. Spin. Okay, 360. Okay, nice. So that is the head of our style. So we said we are going to be using Docker. So it's time to configure the Docker file, the Docker compose for the services. So given that we are using Python, we also need a Python image. It's our base image Docker file. Yes. So usually I use the slim version. It's a bit lightweight and easier to download. So we have Python. Okay, nice. So set the working directory. Work directory. Yes. Then we need to run some commands. So first we're going to update. Okay, so build essentials. I don't think we're going to build essentials, but let's do GCC. GCC. Then okay. Then we have the requirements.txt document here. It is. Then we copy the requirements first. Then we run the pip install the requirements. Yeah. Okay. Nice. Then copy. Okay. Then we're going to be running some command make directory for app data. That is basically the database repository app slash, let's just call it data. Then we're going to expose the 8000 ports. Then we have our environment variables. That is the database URL, the secret key. That is the variables we had previously defined in our main application. Database URL. Data db. Let's do small env redis URL. Before redis we have the secret key env secret key. Let's just move it at your secret key. Then we have env webhook. Remember the webhook URL. Not URL, but secret. Webhook secret. Set to your webhook secret. And is there anything else other than Redis? We have Redis. We're not using the localhost anymore. We're just going to set small Redis, and then the port 6379 is the port that we are exposing it to. And then we have we're not going to run health checks. We are going to basically use univoc and then main up. Have the host, then the 0.0.0.0. That is what we're going to expose. Then the ports, we have the 8000 is our ports, and with that we have the Docker file complete. We have now the remaining part of that is the Docker compose .yaml file. Docker compose.yaml file. It's integral towards managing various services running in our container. Of what's the version 3.8. Define the services that we have. Okay, let's see. Sorry. Services. Our first service is actually API, and we have build on port 8000, and okay, makes sense. Okay, then we have the secret key. Let's just set it to a secret. Secret key, just like the other ones, and we have the webhook, not URL but secret, webhook secret, your webhook secret, and then you have Redis, Redis URL, Redis URL. We have Redis at port 6379, and volumes. Okay. Before depends on, we have volumes. So under volumes we have data. Basically we are just defining the app data, where the app data is. Then we depend on the DB and Redis, and let's set up a restart policy. We're going to restart. Only option to restart is unless it stops. We're going to ignore a health check. Normally we do a health check. Then we have the DB, we have the image we are using Postgres. I prefer using the 15 Alpine. It's a bit lightweight and effective. Then we have the environment, we have the user, password, database. Then we have the volumes. Okay. I'm also going to set a restart policy, but before that I'm going to set the ports to which I expect our DB, our Postgres to be running on. 554.32 makes sense. Again, I'm not going to dwell on health check. The next is Redis, our cache. 7 Alpine. Okay, I don't know. Let's see which ports. The port I had already defined it is 63, 79 Redis data. The restart policy is the same as the other ones, and let's see what's let's put some command here for Redis. Okay, name that Redis dash server. Yes, append only. Health check, I'll ignore that. Then another service that we've not paid much attention to, Nginx, which is very integral. Not the latest version, but I'm going to be running the Alpine version also. Similar to the Postgres database, port 8080, and I'm going to be exposing the admin.html, that is part of my volumes. ./admin.html. This share admin.html makes sense. Okay. The sets, just ignore that. We don't have sets now. And depends on the API, so the API has to run. Nginx depends on this service running first. From there, we're going to define what's our volumes, just like we had defined. And the first one is the Postgres data, and the other one is the Redis data. And with that, we are done with the Docker Compose file. And now we get to configure our Nginx configuration file. Config. So we have the events. We're going to start with the events. So we have the various endpoints. We're going to configure them in Nginx. We have the orders, we have the payments, all of which are very integral. We have payments. Okay, from set header. Okay, nice. And we have the health. We are going to ignore the health. Then we have the metrics. Location. Then metrics. This is the application metrics, similarly to the Prometheus logging metrics. So that's about it. And then the default location, let's delete the schemes, we are going to return 301 slash admin. That is our default location. We could say initial or default location. Doesn't make a ton of difference. So in the admin, it's slightly different from the other endpoints since it's our main endpoint. So we have our alias set up to nginx HTML. Then our index, it's not index.html but admin.html. Then we have the try files, we have yori, then our admin.html. And with that, we are done with the nginx. We are done with nginx. So the next part, what we can do. We're going to simulate payments. That is the payment option. Okay, let's see how it is.